All right, so I'm going to walk through the practice problems. I'm not going to fully solve them. I'm just going to um, give you an idea of how to do each one. And on this very first one, this, by the way, is the document share. I keep forgetting I have it because this is so new to me. So if you're asking me questions, want me to solve something, remind me I have this because I can work it. I have a whiteboard underneath. This is the bad side of the whiteboard, needs to be better cleaned. Anyway, on number one, it gives you numbers. The key to me is this last question: is the system at equilibrium? I know it's a Q problem. The other way you know is you have a bunch of numbers. It does not say you're at equilibrium. It says you have this, this, and this. So you can put them in. Now, what's wrong with what I just put in? It doesn't have a unit. Make sure you put a unit. For the SO2, 0.0050 molar, and for the oxygen, 0.030 molar. And, right, that's my oxygen. These are all initials. I have everything there initial. There's no zeros. It's a Q problem. You set up Q the same as you do K. You solve. So first write out your Q expression. All of these are molarities. You plug in, you solve. You apparently get Q is right underneath 0.19. 0.19. I gave you K. So K, Q, alphabetical order. 0.00407. You can write it in scientific notation. It's usually easier to see in this notation. The Q is larger. The alligator always eats the larger one. The nose of the alligator tells you it removed reverse. What I would need for full work is you would show me that you plugged these numbers into Q. You got this number. You compared them. It shifts reverse. So is the system in equilibrium? It will usually then ask what happens to reach equilibrium. It shifts reverse. If it helps you to write shifts, go for it. Here we go. Next one. So this is how much is placed in the flask, 0.50 moles per 1 liter. So I can just write per liter. And then it wants to know how much do I have in equilibrium. So write your ice. These are not given, so they're zeros. You're going to shift towards the zero. You want to write that arrow because it tells you my reactants are my plus x, my product is my minus 2x. At equilibrium, these guys are just the x, because 0 plus x is x. And then this is going to be 0.5 minus 2x. So we would plug into K, write your K expression, IBR squared. You know what? If I'm going too fast for you, you hit reverse. You hit that back 30 seconds. You should do these all first, and then you can just listen along, say, yep, I got it. And then you can go 30 seconds ahead. All right, the IBR 0.5 minus 2x and squared. And this will be x times x, and K is 280. If you have a TI-89, you'd write TI-89 or Inspire solved. You would give me 2 answers for x. If you do not, you're going to square root both sides. I think we did this problem yesterday. You'd have the square root of 280, whatever that is. My calculator's next door. 0.5 minus 2x over x. You rearrange, you solve for x. You will get my answer up here for your x. And then the IBR would be 0.5 minus 2x, which gives you that. All right, ready for Le Chatelier's? Here's our equation. That tells us it is exothermic. Delta H is less than 0. So if you like, you can write your heat on this side and then put your brackets. You don't have to show the heat. All right, H2O is a gas. Everything's a gas, so we're not going to cross anything out. If I add the H2O, it shifts forward. H2O is a reactant. Can't go backwards. There's a wall there. If you add HCl, HCl is on this side. Can't go forward. There's nowhere to go. So it has to go reverse. You have to use it up. All right, now we're going to decrease. If I take away the oxygen, you move towards the oxygen. If I take away the chlorine, I'm going to move towards the chlorine. So if you take away the oxygen, you move to make more oxygen, which is in the forward. This is why I like teaching where you can see me, because I use a lot of my hands and you can't see that here. All right, expressions. I could have a little camera on up there and you can watch me talking with my hands. Maybe I'll do that next time. All right, temperature is increased. Joey convinces me not to put my face on there. All right, temperature is increased. Heat is on this side, so it goes reverse. The other way, so think of it, endo likes heat. This is exo, so the endo is the reverse. It goes in the reverse direction because the reverse direction is endo. If you increase the pressure, so we got to count moles. You got 4 moles on this side of gas. 2 plus 2 is 4. And on this side, you have 5. 4 plus 1 is 5. Didn't even need a calculator for that. So if we increase the pressure, it's squishing it together, and it goes reverse. Yeah, you need to see all my great expressions I'm making. Having fun with that. All right, what conditions, the temperature and pressure, maximize the oxygen. Oxygen's over here, so we want it to go forward. Well, increasing the temperature went the wrong way, so we want a low temp, so decrease temp. And high pressure went the wrong way, so we want a low pressure, so low. Or we can say decrease temperature, decrease pressure. Again, they're independent of each other. They can be high or low. The temperature is determined if it's exo or endo. Pressure is based on the number of moles. So when we added heat, it shifted reverse. So that will decrease the product, which will decrease K. So K will decrease. All right, I'm moving on. To catch. Joey and I are leaving in a couple hours. And the other big news about today, 6 months until Christmas. Very exciting. It's June 25th as I'm taping this. All right, so this one's a fun one. So it tells you put 5 grams of this in, and students start doing all this math, and they're like, how can I do it? You didn't tell me a volume, and they get all worked up. How can I find pressure without the volume? They go, okay, they get their periodic table, they get their moles, and then they're like, what do I do? What's the temperature? Do I just assume STP? What do I do? Oh, but somebody's going, oh, that's a solid. It doesn't matter how much solid you have as long as it's there. I have none of these to start with, so they're starting at 0. So they're both a plus X. It's my ice chart. Solids don't matter in the ice chart. So in equilibrium, these guys are each X. Let's write our K expression. K is just the pH3 times the BCl3, because they're the gases. And it's a KP, so whatever we solve for is ATMs. So you just plug in that your K, the 0.00187, again, I don't know why. You can analyze me, equals X squared. You solve for X, you get my number there. And then if each one of these is that number, the pressure of the pH3 plus the pressure of the BCl3, this would be how you write it, equals P total. This is how you write partial pressures. Pressures you can add up. So X plus X will equal the total pressure. So you solve for X and then you add them together and you get the total pressure, which must be double that number. There you go. Okay, so I have 0.0432, which implies I might have a mistake. So you guys keep going. I have to find a calculator. No, I found it. There's a way I can stop it, but I found it fast. Let's just do this. 0.00. Oh, I don't know why I have that extra 0 there. So yeah, P total is 0.0865. 3 sig figs because we didn't use the 5, and it has a unit ATMs. How do I know I'm in ATMs now, not molarity? that little p there, that little p. All right. All right, let's see at the next one. All right. It doesn't say we're at equilibrium is when we get to that part. So initially you have 1.2 moles of CS2 is mixed with 3.6 moles, and we're in a liter, so per liter. So neither of these are there initially, so there's 0, I, C, E. Learn to write delicately. So we're going to move towards the zeros, minus x, minus 3x. Don't miss the 3. Plus x, plus x. So at equilibrium, the carbon tetrachloride is 0.9 moles, and we're still in a liter. So at equilibrium, x is 0.9. So that means this is also 0.9 because it's x from this. And then I can figure out that. And then this will be 1.2 minus x. So this will now be 0.3 moles per liter. And this will be 3.6 minus 3x. So 3 times that is 2.7. So this will be 0.9 moles per liter. Then you write your K expression. And you know what? If I'm going too fast, stop me. That's the beauty of the videos. See, this is actually better. So I was teaching you in there. I got a message. I heard my phone go off. So I looked at during the break while I moved over here. Apparently, this is how we're going to be for a while. So exciting. All right. Don't forget that's cubed. Plug all your numbers in. You would actually show me you plugged it in, and you'll get 3.7, 2 sig figs because all my numbers up. Oh, well, yeah, I try to avoid that. We should keep 2 sig figs. If you want to go with the rule this term, everything has 3 sig figs. I love that. It's a wonderful rule they use in. All right, we're going to do something here. Look, you can see me now. All right, this drives me crazy. But you can see all my, yeah, you can see all the chaos behind me. There's all the gnomes for those of you who missed the gnomes. Or you want to add a gnome to the collection, and fairies. I was thinking I need more fairies and mermaids and stuff like that. All right, I look at myself instead of the camera when I'm talking to you. I haven't learned how to do that yet. Let's do this one. Oh, we have a percent. All right, 0.5 HI. Let's just start. Let's write down what we know, 0.500 ATMs. We're going to find KP. If it asks you to find KC, you would have to do the whole chart in ATMs, and then you can use PV equals nRT, which we can't do because we don't have a temperature here. But we're going to do KP. This should say that. These are zeros because I didn't give you a number for them. So it's shift reverse. These guys are plus x. This is minus 2x. So at equilibrium, this is 0.5 minus 2x. All right. We can write our K expression over here. HI squared over hydrogen and iodine. And let's see, what do we know? 15% decomposes. So it's not telling you 15% is left. If we take that 0.500, which is my initial ATM, times the 0.15, so times the percent that decomposed, that gives me the change. So 0.5 times 0.15 is 0.075. Now, please notice that I labeled. You're going to be showing work at some points, worksheets, homework. You pretty much get the points as long as you show up and say hi to me and introduce yourself and ask one question maybe. Worksheets, I am more than willing to give you advice. You can share the screen. I can look at it before you submit it, but it is based on showing your work besides just getting the answer. So showing your work beautifully. All right, there's my change, which is not x. So be careful. It is the change here. It is 2x. So these guys, so that would mean 0.0375 is x. Oh, that's what we have there. So we'd plug these in, we'd solve, plug it in here. Pretty confident that's my answer. All right. Again, my office hours are all about you guys coming and saying, can we go over page 7? These are from the book, Coates' book. We used that book for the first 23 years. It was only 2 years ago we went to free because they became astronomically expensive. They kept doing a new edition every 2 years. But Dr. Russell and myself kept that book because they do the best job with equilibrium. For this term, it is the book to use. I've never looked at anything else because they do a phenomenal job. All right. Oh, number 7 looks like Hess's law. We got 2 equations. We're trying to find the final one. Again, stop me, do the problem, and then watch because I'm going to go fast. All right. That is the piece I want from that first equation. I cannot change this equation because that's what I'm solving for. So I'm going to double. That becomes a 1. That becomes a 2. Write your pieces in. I'm not doubling k. What am I doing to k? Since I doubled, I take it as the exponent. So this one, you doubled, you take it to the power of 2. All right, that gives me my 2NOBr. In my next equation, I want the nitrogen and the oxygen, but they're on the wrong side. So my first equation, I double. My second equation, I flip. And so we get nitrogen plus oxygen goes to 2NO. There's my bromine, there's my nitrogen, there's my oxygen, my 2 NOs. When I flip it, this becomes the -1. So K net equals K1 squared over K2. Because when we say it's -1 power, it means it's in the denominator. This number, what does that number mean? Because I will ask you that at some point. K is less than 1. It's much less than 1, so it is reactant favored. Don't tell me it doesn't happen. Just say reactant favored. Probably doesn't. Really, not much is happening. Reaction really didn't much. But do tell me it's reactant favored because sometimes you're only given forward or reverse. Yeah. Favors the reverse. Seriously favors the reverse. Okay, I like this question. All right, heat is here. Heat is on. There's my arrows. So this is endo. This is an endo reaction because heat is on the reactant side. You don't have to put the brackets. Student, these are all tricks students have taught me over 25 years. Ends up being really good in this format. All right, dragon. I'm the year of the dragon. Figure out how old I am then. 5, 6, I don't know. I'm 8. I don't know. All right. Actually, female dragon is a phoenix, so we regenerate. Go figure. So the dragon breathes on it, heats it up. Got to use the heat. Loves the endo. Absorbs all that beautiful, wonderful heat from the dragon. Maybe it's a super hot day when you're doing this. I don't know. It's a month from now. All right. Oh, and then a unicorn comes along and poops and gives us an inert gas in there, and the pressure increases. Oh, that's why I have this question. Nothing happens. So no change, and C you can write, because there are 2 moles on this side. I do not know what unicorn poop is made of, but it's inert gas apparently. That's what the gnomes have told me. That's 2 moles on each side. No change, it's the same number of moles. So pressure and volume have no effect on this reaction. Pretty cool. And then we're gonna Pegasus. Pegasus, that flying. And he breathes in hydrogen. That's over here. That's gonna shift it reverse. All right. I am having a worried moment. Did I answer these questions right? Yeah. All right. And then Yeti. Yeti is Bigfoot's Himalayan cousin. Last weekend, I was up in, we were going around Mount Adams, Mount St. Helens, and that's like Bigfoot territory. It's awesome. And Bigfoot had his mask on and everything, but there's a story I heard, and it's this wonderful story that Bigfoot, that they're actually from another dimension and they're on vacation. And that's why we can never find them, because sometimes they return to wherever they're from, but they're here on vacation. And that's why they find the most wooded places. That's an awesome story. Yeah. All right. So, you know, Aaron is down at his lookout tower, and I'm thinking he's gonna meet Bigfoot. All right, want to hear another story about Bigfoot? You can just like fast forward 30 seconds. You don't have to hear my stories. So I did a shaman, like when I was your guys' age. I was in Salt Lake City. This is before Joey. And it's this thing. I went on this shamanic journey, right? And so they play this drum and you sit there and meditate. And oh boy, you go, so you're supposed to go into a hole. You have to find a hole and you go into the hole and then you're going to meet your mentor. And I don't know how long it lasted. I had the worst headache after because I kept fighting my hole. I had just been to Nepal, and there's a lot of huge crevasses beyond anything you can imagine. And I kept trying to go in this crevasse. And I finally was told, this thing's drumming on, all these other people are off in wherever their world is. This is the weirdest part. Everybody else had an eagle guide. They're all like, oh, because this is in Utah. Oh, an eagle took me soaring over. Oh no, so finally it's like, that is not, because my friend in Nepal had been terrified of this hole. So I finally went, okay, fine, that's not my crevasse. I'm supposed to go down. I go down this crevasse and suddenly appears there. And a Yeti presents me with tea. A Yeti, yes. And I'm like looking at him going, are you freaking kidding me? My guide is a Yeti. And then she started playing the drumming that pulls you back. So I had some chai with this Yeti, and I've gone on a shamanic journey since then. All right. And then I did not share my story. I'm extremely introverted. I don't know why I'm telling you guys this story. There we go. So that's my story about Yetis. And the Yeti, they're big, they're strong, they're interdimensional, and he squeezes it. No change. No change. Because it's the same number of moles. Same moles on both sides. All right, pressure, no effect. Temperature, the dragon, heat made it go forward. We want a high temperature. Pressure is no effect. I know. Was that a trick question? No. It was a learning moment. You learned. Congratulations. All right, we got another question. F. The dragon breathed on it. So as we increase temperature, the dragon, you guys get to draw a dragon at some point in the term. I'm serious. You won't get full credit unless you draw a dragon. So you can practice now. All right. Notice I'm not drawing a dragon because I gotta go catch the train. Shifts forward, that increases the product. And so you increase K. If it had been exo, it would have shifted reverse, decreasing the product, decreasing K. Only temperature changes K. All right, last question. So we're making a chart. You mix. It doesn't say you're at equilibrium. Let's go way back to the very first page. Page number 1. I'm going back. Very first page of our notes. This question. See how it started out at equilibrium? On the midterm, this is the most missed question. It's like, easy question. It says at equilibrium. Everybody tries to make these elaborate ice charts. And then, yeah, it's a student who just goes, oh, look, at equilibrium. I don't need an ice chart when I'm at equilibrium, but we're not in these. That's why we're doing practice. All right, we're making, because you're mixing. The iodine, 0.50 moles, write your units, with the bromine, 0.50 moles. And we're in 2 liters. So you can, we'll change it eventually. And so the IBR is 0. These guys are minus x. This is plus 2x. So at equilibrium, these guys are 0.25 minus x, 0.25 minus x, and this guy is 2x. 68% of the iodine reacted. So we had 0.25 molar in iodine initial times the percent And you have to be careful, it is the percent that reacted. So that is the change. It doesn't say 68% is left. So times 0.68. Oh good, my neighbor decided to do their yard work. All right, this is, the change is 68% has reacted with 0.17. That is the iodine. That is X. That's why I wrote that there. You would finish your chart here. So this is 0.25 minus that, so 0.08. 0.08, you can stop me at any time. It's magic of this world of videos. 0.16. Oh, what is wrong with my chart? It has numbers that are not with units. So a reminder, in the chart, you have units. When you're solving for K, when you're solving for K, you can leave the units out. They have to be molarity. When you're solving for X, K has to be in molarity unless it's a KP problem. We saw some of those. Let's write our K expression. Always has to be there. I'm in a dilemma. If we're going to do I'll show your work, how do I keep you all from cheating? Could we just meet at a park and all like do it outside? All right, but you have to bring your own chairs because you can't even sit on the ground anymore. All right, you plug these equilibrium numbers. Initial numbers do not go in. Initials would be Q, and you can't plug them in anyway because it's 0. So we have those numbers. You get my K. Oh, what does that value of K tell you? It's not a big K, but K is greater than 1, so it favors the forward direction. Doesn't matter how big it is, as long as it's greater than 1, it goes forward. Let's look at B. All right. Oh, K suddenly is less than 1 at a much higher temperature. So up here we were at, a warm room, which is right now, it's summertime. So if we increase the temperature, we decrease the value of K. I gave you the answers there, but do you guys see that? So if you decrease K, that means you decrease the product, right? Because it's always P over R. That means it must have shifted reverse. Temperature, high temperature likes endo, so the reverse is endo, so the forward is exo. You'd have to be able to explain that. And maybe has a brilliant idea how I can do tests without you cheating and have them timed. Not make more multiple choice. I don't think multiple choice does much. All right. That's it. Many blessings and safe. Have a beautiful, I guess when you all watch this, I'll meet you in the next few days. Oh, there I am. I have to figure out how to stop recording.